Hello, I'm speaking to you from Australia, so as is customary I'd like to start with acknowledgement of country. I'm speaking to you from the lands of the Wurundjeri people of the Kulin Nation, and I wish to acknowledge them as traditional owners. I'd also like to pay my respects to their elders past and present. Let me quickly introduce myself. My name's Alec and I work at Papercut in Melbourne, Australia. And you can find me in all the usual places as Alec the Geek. I'm going to be posting a link to the slides and anything else on Twitter and also on LinkedIn. So if you've got any follow-up questions, if I'm not around today to answer them, then please don't hesitate to reach out to me. So I'm going to be talking about Docker's code, so I'm going to quickly introduce that. So Docker's code is an adoption of modern software techniques to create documentation. So at the end of the day, it's about getting the whole of the product team involved in creating documentation, from traditional technical writers to developers, product owners, user representatives, and so on and so forth. And it's about doing it as productively as possible, and that means using automation. So what is a practical level? What does that actually mean? It means that we're storing content as text files. We're using lots of tooling. We're using developer-style workflows, things like change requests and CI/CD platforms and that sort of thing. And you can find lots of information out there. I've put some search terms and references here on this slide for you to look at later. But the downside to Docker's code is that there are lots of moving parts. So things like API visualization tools, tools to generate diagrams from text, static site generators, as I hinted at earlier, linting tools, build tools, and so on. So all of those tools can be hard to deploy and maintain across the whole team at all their workstations. So what do we actually need to provide our writers with? And again, emphasize when I talk about writers, I'm talking about the whole of the team. So when people are making changes to the documentation, they need to be able to preview a high fidelity version of the change they're making. Can they see what the consumer will see, and therefore can they validate it? Can they make use of the verification tools that we provide in the system to do a verification locally on the system before they push the changes? Are all these tools easy to set up? Is it easy to install updates? And do they not have to learn new technical skills in order to use this system? So that's where Docker comes in. So Docker's promise to developers is to manage complexity and that's the thing that we want to do for writers as well. So I'm going to propose three things you need to do. The first is that you need to use Docker to generate a standard set of documentation tools bundled together. You could bundle them into a separate image, and that's what I've been most productive. It is possible to use separate images and perhaps use something like Docker Compose, but I think that would be more complicated. So I do personally recommend the single big image approach. And you create and manage that image with CI/CD version control automatically. So and again, this is about taking away complexity and new skills away from your users, or from your writers rather. Once you created a standard toolkit for folks to use, all they need to do is to install Docker Desktop and make sure that they understand how to use Git or whatever version control tool you're using, and they've got access to their favorite text editor. So once that's all set up, they can then sit down and start to do productive work at their workstation. And probably the easiest way to show you this is to actually show you this. So I'm going to jump in to my text editor and start making changes. But before I go there, I'll actually give you a bit more detail about what I'm doing. This is a demo documentation site that I created for you. So it's got some content here, and there's actually a GitLab repository behind it. I'm using GitLab in all my examples for CI/CD and version control. It's not required. You can use whatever you want. Okay. And if you look into this section here, so we're here in the Docker build context directory, you can have a look at the Docker file and the build scripts that I'm using later on. So what I want to do is actually want to go into this content and make a change. So I've checked out a copy of the site and I brought up, I'm using restructured text rather than Markdown. but I can just put some content in here. In fact, before I do that, let me bring up the local site. So I've actually got some helper scripts. So I've written a helper script called Run Doc Tools. So again, hiding complexity from people. You can imagine that you might actually attach this script to a button so people can just click on it rather than having to drop down the command line. And all it does is, in this case, is a script that runs a Docker container with bind mounts and passes in the parameters that are going to happen. And you'll see that in action in a minute. So now I can just say make the HTML. So it's going to go through. It should be pretty quick because the pages are already there. And now I can actually open up that static content because I'm using Sphinx. If I was using something like Hugo, then I'd probably have Hugo in development server mode. So the specific mechanics vary by toolset, but you get the idea. And that brings up a local static version, so I can actually see my changes. So if I jump back to my content and save this change, I can build the site again. And this time, as well as actually building the site, I'm actually going to run the verification to see if there's any spelling mistakes or things like that. And it has actually found spelling mistakes. It's also found some broken links. But if I jump down to here and do a refresh, you can see it's immediately shown me what would happen if I push this to production. So I'm getting an immediate feedback, and I'm able to run the local verification tools. So let me be unprofessional and actually try and commit that change. And what's going to happen is that I've got the pre-commit hook built to actually run the verification test as well. So I'm getting automation built into my system. And again, the verification test will fail, so the commit will not work. So I've immediately enabled local writers on their workstations to accurately preview the content and make use of all the automation tooling that we built for the server side. Now, in order for this to be meaningful, you have to use the same toolkit to deploy your content. So again, this happens to be a GitLab example, but that's nothing magical about that. You could be using GitHub or your local infrastructure. The point is that for both the previewing and editing of the content, I'm using the same set of tools as I'm using for deployment, so there's no surprises when I deploy. This is what we do at PaperCut, and it saves a lot of time. So in summary, I'm saving a lot of money not having to buy proprietary tools, not having to train people on them, or spin up special infrastructure. Containers, version control, and CI/CD are the key technologies in my processes. And with it, we can work a lot faster because we're all using the same things and we can share common practices. The work in progress timescales are very quick. I can get individual changes out within seconds. And the productivity boosts from automation are huge. So that's all built on top of Docker. Docker is hiding the complexity for technical writers in the same way it does for developers. So this is a link to the content that I showed you earlier on, and as I say, I will be posting these slides to Twitter, so you'll be able to get hold of this as well. Thanks very much, and just a quick mention that PaperCut has some job openings, so if you're interested in that, please look at this link here. Thank you very much.